Hello, welcome to my channel. We have been solving these past papers. This is right now I have this mathematics paper 6 probability and statistics, and this is May-June 2024. So we have already solved a couple of questions. So let me do question number 5 right now. We have solved some questions, some skipped I guess anyway. So right now I will do question number 5. Okay, here you go. Okay. Sale of cell phone at a certain shop occurs using randomly, singly, and independently. Okay. State one further condition that must be satisfied for the number of sales in a certain time period to be well modeled by Poisson distribution. Okay, Poisson distribution is a discrete distribution and it is related to queuing theory. And it says that in a certain time period t, the number of occurrence of something, so probability of this variable x equal to a, this is equal to e to the power minus lambda. Now lambda is a parameter for this distribution. And then lambda power a over a factorial. Okay, so this is, and lambda is the average number of occurrences in per unit time. Okay, so state one for the condition that must be satisfied. Yes, so for in order for this distribution to be Poisson, it has to be singly occurring, randomly, independently, and the average rate should remain constant. Okay, so average rate should remain constant throughout the time. So then we apply this distribution. Okay, so this was the part A. Now part B is more interesting. It says the average number of sales per hour is 1.2. So we say that it is Poisson distributed with the parameter 1.2. Okay, now assume now a Poisson distribution in a is a single suitable model for the probability that the number of sales during a randomly chosen 12-hour period. Okay, so if in 1 hour it was 1.2, so in 12 hours it is going to be 1.2 times 12, so it's going to be 14.4. So for 12-hour period, we will say that it is Poisson distributed with parameter 12.4. Okay. Okay, will be more than 12 and less than 16. Okay, so we need to calculate that this x is this variable, this random variable, it is more than 12 but less than 16. Okay, so it means that the probability that x is equal to 13 plus probability that x is equal to 14 plus probability that x is equal to 15, right? More than 12 and less than 16 is these three probabilities. Okay, and if you remember, I told before earlier that probability that x is equal to a is equal to e to the power minus lambda, where lambda is the parameter, this one, whatever is it, right? And lambda power a over a factorial. Okay, so the probability that x is equal to 13, it is e to the power minus 14.4. Remember the lambda for us is 14.4, this one. Okay, uh, and 14.4 power 13 divided by 13 factorial plus e to the power minus 14.4, 14.4 power 14 over 14 factorial, and finally e to the power minus 14.4, 14.4 power 15 over 15 factorial. Okay, so we need to simplify it. Let me take it minus 14.4 common outside, and then I have 14.4 power 13 over 13 factorial plus 14.4 power 14 over 14 factorial plus 14.4 power 15 over 15 factorial. So let us calculate this thing. Okay. Uh, if I do it separately, e to the minus 14.4, and inside I know how big or how small it will be. So 14.4 raised to the power 13 divided, sorry, 14.4 raised to the power 13 divided by 13 factorial. Okay, this comes out to be okay, 183, 836.64. I don't know if I should go to that much precision. Okay, and then we have 14 factorial, and here I have power 14, and this gives us 189 and 089, 089.12 plus 15, 181, 525.55. And when I simplify this all, uh, e to the power negative 14.4 and multiply it by 183, 836.64 plus 189, 089.12 plus 181, 525.55. Okay, so when I calculated all this, it comes out to be 0.309. Okay, so this is the probability that in 12-hour period, we will have sale between 12, no more than 12 and less than 16. So this is a 30.9% probability. Okay, I hope this is clear. Now the C part of the same problem, it is use a suitable approximation distribution to find the probability that the number of sales during a randomly chosen 1 month period, 140 hours, will be less than 150. Okay, so 140 hours. In 1 hour, it was 1.2. So in 140 hours, this comes out to be 168. Okay, so now we are talking about a Poisson distribution with parameter 168, right? Okay, now this time we have to do the probability that x is less than 150, right? It means we have to find the probability that x is equal to 0 plus probability that x is equal to 1 plus up till probability that x is equal to 149, right? Okay, so if you remember, probability of being 0 is e to the power minus 168, and then 168 power 0 over 0 factorial. Next is e to the power minus 168 and 168 power 1 over 1 factorial. In the same way, we will go up till e to the power minus 168 and 168 power 149 over 149 factorial. Am I right? So I can simplify it as 1 e to the power minus 168, and inside I can say this is summation of 168 power n over n factorial, where n goes from 0 to 149. Okay, makes sense? Now this is going to be a big calculation. Okay, we had to use some computer program to do it, or we cannot do it manually. So we need to approximate this Poisson distribution. So for large number of this kind of thing, this Poisson distribution, it become normal distribution. Okay, so we can approximate it with a normal distribution with mean 168. Okay, and variance is also 168. Okay, so now what we have to do, remember we have to calculate the probability that x is less than 150, right? So this would be equal to uh, probability. Now I'm assuming that it's that this x is normally distributed with these parameters, right? Okay. Now, since it is normal, I'm taking it as a continuous random variable now. Okay. So if it is continuous and x is less than 150, I will not say that it is exactly 149. It's up to 149. I will say to get a better understanding, it is 149.5. So between 149 and 150. Okay, so I will assume that I have to calculate that the probability of a random normally distributed random variable z, it is less than and 168 minus 149.5 and divided by 168 under the root. Okay, I have to calculate this thing. Okay, why? Remember, now I'm assuming that this x is normally distributed with variance with mean is 168, right? And it has a variance of 168 as well. And I have to calculate that x is less than 150. 150 somewhere here. Oh, sorry, 149.5, right? So I have to calculate this probability, right? Okay, so I will normalize this x. Instead of x, I will change it to z, but z will be uniformly, normally distributed with variance, with mean 0 and variance uh, 160, variance 1, sorry, variance 1, because I have normalized this thing. Okay, so if I have to say that, probability that x is less than 150 for this distribution, it is same as that z is less than this number where z is normally distributed with zero mean and unit variance. Okay, here x was normally distributed with this mean and this variance, but z is this one, where the transformation from from x to z is given by this expression. Okay, so this is equal to probability that z, which is a normally distributed random variable with zero mean and unit variance, it is less than, if I calculate this amount, uh, it is 168 minus 149.5 divided by square root of 168. Yeah, so this comes out to be 1 for 1 point, sorry, 1.427. So 4273. Okay, so we are saying that probability that z is yes, I think I had to put it negative here because 168 minus, anyway, so this is negative, this is positive, so it will be negative. So z is less than, this is negative 1.427. So this is the area I'm talking about. Okay, so we can calculate this thing with Q function. Remember, this area is same as if I have the same curve. So I will take 1.427 and this area, right? And this area can be calculated from a Q function with value of Q is 1.4273. I will approximate it with Q 1.43 because I will tell you why. Okay, so this is what we need to calculate. And in order to calculate this thing, we need to use the standard tables. Okay, so let me share the table for with you. How do I do that? Let me see. Oh my goodness, I forgot. Yes. Okay. So I will share. Okay, hold on a second. Yes. Okay, I will share this page with you. Okay, so can you see it? So now I have to go from 1.4 to 3. 1.43, sorry. So 1.4 and 3 is this thing. So this is the value I'm talking about. Okay, 1.4 and 3. Okay, 1.4 and 3. Okay, so let me go back. It is 0.7, 0.07636, right? Okay, let me go back. Uh, mm, where was I? Yeah, over here. So, okay. So I have, you can see this one. Okay, so we calculated, not calculated, we saw the table, and this value came out to be 0.07636, or it is 7.636%. Okay, so this is the probability that in 1 month period we will have less than 150 sale. Okay, I hope this is clear. If you ever have any question, you can always ask me in the comment section. If you find these videos beneficial, then please subscribe my channel. Thank you very much for watching. See you in the next video.